These kind of problems, when you find the limit, you may think that they do not exist. Why? Because the numerator may go to 0 and the denominator to 0, or the numerator may go to infinity and the denominator to infinity. So when you have this kind of form, they are called the indeterminate form. So instead you use the L'Hopital's rule. So the L'Hopital's rule says the limit of the quotient of a function is just the same as the limit of the quotient of their derivatives. So in this case, you realize that as x goes to 0, natural log of x goes to infinity and x also goes to infinity. So we cannot have infinity over infinity, which is indeterminate. So taking the derivative of the natural log of x is just 1 over x, and the derivative of x is just 1. So this is just the same as the limit as x goes to infinity of 1 over x, which is just 0, because as x goes to infinity, 1 over x goes to 0. The limit of x, natural log of x, as x approaches 0 from the right, you can see that as x goes to 0, we have 0, and the natural log of 0 is undefined, right? So this is an indeterminate. So we can write this problem as the limit. Now let us write the natural log of x multiplied by x as natural log of x. Let me divided by 1 over x, right? Because I can choose to multiply the numerator by x and the denominator by x and x cancel. So this is just the same as x multiplied by the natural log of x, okay? Now that we have the limit of natural log of x divided by 1 over x, we can take the derivative of the numerator and the derivative of the denominator using L'Hopital's rule. So this is just the same as, you can see that the derivative of the natural log of x is 1 over x, and the derivative of 1 over x is negative 1 over x squared. So let us go ahead and multiply both the numerator and the denominator by x squared. So this becomes we just have the limit as x goes to 0 from the right, negative x, which is equal to 0. Let's compute the limit of x to the power 2x as x goes to 0 from the right. So the first step of these kind of problems, you can see that you have it is of the form 0 to the power 0, right? But this is indeterminate. So let us go ahead and use logarithms first, right? So let us go ahead and you can put y to be equal to x to the power 2x. Then apply the natural log on both sides of the equation, so that this is natural log of y is equal to 2x natural log of x, okay? Now that we have natural log of y equal to 2x natural log of x, we can apply the exponent on both sides. So y is equal to exponent of 2x, exponent of 2x natural log of x, okay? Okay, therefore our limit becomes, so we said y is this expression, right? And we have a new expression for y. So we have the limit as x goes to 0 from the right of our new y, which is e to the 2x natural log of x, okay? Now this is an exponential function, so we can take the limit in the exponent. So this is e to limit as x goes to 0 from the right of x natural log of x, okay? But we find the limit of x natural log of x as x goes to 0 is 0. So this is just same as e t to the 0, which is equal to 1.